Welcome all of you. Today we are going to see about paging, one of the important concept in OS. Before that we must understand what is meant by memory, logical address, physical address, memory management unit. First we will see about the basics in some of the basic concepts in the memory concepts. If you want to execute any program, that program must be brought into the main memory for the execution process. Already we saw about the process states in detailed manner in the previous video. If you have any doubt means please refer the previous video. In this process states, if you want to execute the program, that program brought into the ready state in which the input queue is present. User programs goes through the several steps before its execution process. Next, we will see about the logical address and physical address. Logical address is generated by the CPU. It is also referred as the virtual address. Whereas physical address is the address seen by the memory unit. It is nothing but the real address that is present in the disk. I will explain with this with an example. Suppose you want to see a film means first you will reserve the ticket and then we will go to the theater. The ticket in your hand which is reserved is not the real one, it's just a representation of the seat number. It is just like a virtual or logical address. But the real seat is present in the theater. That is like a real memory and the physical address. Next topic, MMU. It is one of the frequently asked concept or question in the interviews and the exams. MMU is an acronym for Memory Management Unit. It is a hardware device that maps the virtual address to physical address. Next page, in this diagram, the actual address is 346, but the memory representation in the physical memory is different. So with the help of the relocation register, we add some value to exact conversion. This is one of the important functionality of the MMU. Next we will come to the main topic, paging. Generally logical address space is non-contiguous, so the process is allocated physical memory for the execution. Already I told two types of memory are there. One is the logical memory, another one is a physical memory. The logical memory is divided into blocks of same size called pages. Physical memory is divided into fixed size of blocks called frames. See the second and third point in the screen. Once again I repeat, logical memory is divided into pages, physical memory is divided into frames. We have to keep track of all the free frames. Next we will come to know about the page table. Page table is one which translates the logical address to physical address. In this address translation scheme, there are two main parameters are there. One is the page number, another one is the page offset. Page number is P, page offset is D. The page number is nothing but it is used as an index which contains the base address in physical memory. Page offset is one which represents the limit combined with the base address. What I told is represented in the diagram. CPU represents the process for the memory. In this diagram there are two parameters are there, P and D. P is the page number and D is the offset. With the help of the page number P, we find the page F. F and offset D are combined to find the pages in the frames for the process in the physical memory. Here we can see the example for paging. In the logical memory there are four pages are there, page 0, page 1, page 2, page 3. Next in the physical memory there are 7 frames are there from 0 to 7. In intermediate a page table is present to represent the pages in the frames. Actually in the page table we can refer the page 0 is present in the first frame. So it is represented in the physical memory. Next page 1 is present in the fourth frame. Next page 2 is represented in the third frame. Next page 3 is represented in the seventh frame. Let us see another example for paging. In this diagram there are two representations are there. One is the before allocation, another one is the after allocation. In the before allocation, first we will see that we will discuss about that. There are 4 pages, page 0, page 1, page 2 and page 3 in the secondary storage. Free frame list are 14, 13, 18, 20 and 15 in the frames. After allocation, in the after allocation representation, we have to create a page table. This page table acts as a index to refer the pages with the help of physical memory. In the after allocation process, in page first we will take the page 0. The first free frame list is 14, so page 0 is inserted or stored in the 14th frame. So in the page table we can represent that 0 is represented in the 14th. Next page 1, next free frame list is 13, so page 1 is stored in the 13th frame, that is also represented in the page table. Next page 2, next free frame is 18, so page 2 is stored in the 18. Next page 3, next free frame list is 20, so page 3 is stored in the 20th frame. These all processes are represented in the page table. At last, only one free frame is the 15. From this we can understand the two processes, before allocation and after the allocation. Next we will see about memory protection. Memory protection implemented by associating protection bit with each frame. There are two types of protection bits, V and I. V represents valid, I represents for invalid. Valid indicates that the page is in the process logical address space and this one is the legal. Invalid represents that the page is not in the process or logical address space. It can be represented in the diagram. Here see the diagram. First see the page table. 0th page is present in the second frame. In the next one is the V. V represents the protection bit. That represents the page 0 is present in the physical memory. We goes to the 6th page. Page 6 is represented in the page table with the help of page number 0, but the protection bit is I, so invalid. So page 6 is not present in the physical memory. Here page 0, page 1, page 2, page 3, page 4, page 5 are present in the physical memory, so protection bit is represented as V. Page 6 and 7 is not present in the physical memory, so protection bit is I, that represents invalid. Next we will see about the page table structures. There are three types: hierarchical page table, hashed page table, inverted page tables. Hierarchical page table is nothing but breaking up of page table into more than one. In this diagram we represent a two-level page table. Next, hashed page table is one in which hashing function is used for the reference. Next, third one is the inverted page table. In this, page number is represented in the reverse order.